This is a video where I'm going to try and make a useful program in Haskell. So I have images of chessboards, so I'll show you one of them. Here's an example. And I'm going to try and read one of these images into the program and split it up into the squares of the chessboard. Then hopefully write a program that classifies the different pieces. And then the final goal is to convert an image like this into FEN notation. But I think first of all, I'm just gonna try and make a program that splits an image like this up. That's the first goal. So let's get started. I looked up libraries in Haskell to read images, and I found the Juicy Pixels library. So it seems simple, so I'm gonna try and use that. And I did some work to see that the current directory in Haskell is really the directory of the project. So as you can see, if I list the current directory, it finds the two JPEG images. So I think since I loaded the Cabal project, the codec picture should be in here. And now let's see, read JPEG. Yeah, let's just first ask Haskell what this thing does. So it expects a file path, which I think is just an alias for string. Yeah. Wait, type. I think that's an alias, yeah. Okay, so let's just try doing read JPEG. Okay, so read JPEG returns the IO monad of either a string or a dynamic image. Okay, so let's try doing read JPEG of, oh wait, I forgot what it's called, CB002 or something. Okay. Read JPEG CB. Oh, let's do the first one. Okay. Yeah, I should. What? So this didn't. So I probably need to do this in like. So let's see. It returns an IO, so we need to use the bind. So let's see. Do image, or let's call it JPEG. Oh, oops. Do JPEG, read JPEG CB1. Let's see what that does, and then put string line JPEG. Yep. Okay. Couldn't match expected type list of characters with actual type, either string or dynamic image. Okay. So I don't really know how the either type works. Okay, that's a lot of info. Wait, let's so either is just a type with two constructors for left and right. So we can pattern match on that. I think it's better if we start writing this into a file probably, so we can work with it a little easier. Here we go. So read first, or let's do read or print JPEG is of type IO of nothing. print JPEG is due. Read JPEG. I don't know. Okay, read JPEG. Or let's say it takes a string for the file name. File path. And then we do read JPEG of F. And then we call that JPEG. And then we do match. No. Maybe we do a function that takes an read JPEG. It returns an either of a string or a dynamic image. So let's make a function that takes an either of a string and an image. So what is that going to be called? If left string or left string, it takes an either of a string and a dynamic image, and it returns a string. Is that going to work? I have no idea. Delete till the end of the line. Okay, so it takes the either, and then takes. How does that work? So now we need to use pattern matching. Oh, maybe we can just do it like this. Left. A left either, or yeah, so that's going to be a string then. So a left of S is S, and okay, maybe that's just enough. So that's a unsafe function, right? Left string. Now we can do put string line JPEG. Nope. Let's see. Tab character found here. Okay. So that's probably like a NeoVim problem. And this can just be, I don't know why I put that. Oh yeah. This needs to be left string. And I don't know why that is there. Okay, now this. The constructor left should have one argument, but has been given none. What? I gave it S though, right? I don't know what it's saying there. Parentheses, yeah. Okay, let's see how this works. Reload. Okay. Print JPEG. CB001.jpg. Is it CD? No. I forgot what it's called. Chessboard CB. Let's see. Yeah, it was called CB. So let's put that in our file actually. So well, let's see. Let's just call it board image is a type string, or let's say file path. Board image is chessboard001.jpg, and let's do this, delete till the end, print JPEG, board image. And reload and run main. Oh, exception. Non-exhaustive patterns. So, okay, so that means we're getting a dynamic image back, I think is what that means. So let's see what the fuck a dynamic image is. Dynamic image. That's very big. Dynamic image. Wow. So a dynamic image can be a lot of things. Maybe the string thing in the either type is just to give back errors. Let's try running print JPEG with foo.jpg. Haha, yeah. So that the left argument of the string of the either there is just used as a as an error. So that's interesting. They could have like defined a type alias to let us know that that's an error. Okay, so the dynamic image has a lot of constructors. How do we figure out which one it is, though? I have no idea. Maybe. Is it an instance of show? It is not. Oh my god. How do we figure out which constructor we got? Man. Let's see. Maybe we can just how do we do this? Maybe we can just try and print write, and then we take that type and we just do IO of nothing. I don't know what that's called actually. Unit or something. Print write of write image is put string line image. Okay. Okay. Let's look on Google. Dynamic image. What is this thing? From dynamic image. Okay. I have no idea. Let's just take a look at this thing. There's no way to like convert this to a string or something. There's some explanation here. An image in color, grayscale. How do we like unpack one of these? That would be, oh, okay, these are just the constructors. So if we match on it, we get an image, right? So let's see what we can do with an image. The main type in this package, one that most functions work on, is image. So what is an image? Data image. It's a vector of pixel-based components. I've never worked with the vector before, so let's see what that is. Vector. Vector is a lot of things. Instances. Oh, data vector. It's not a type class, right? I think. What is a vector? Tell me. A vector is it has one constructor. It takes an integer and a foreign pointer. Okay, I don't know what these exclamation points mean here. how do we iterate over a vector or like do something with the vector? Okay. How do we figure out which one of the constructors we get back is the question. Because maybe we can just say ourselves like, oh, we're defining an instance of show that takes a dynamic image and then we try and print it. But I don't really, instance, yeah, show dynamic image. No. No explicit implementation for either this or show. Okay. Implement show for data type Haskell. Make a data type instance of show. Let's see. Yada. In order to, okay. So it's, what is it telling us? Can't we just have like a default constructor? Because, oh yeah, instance. I hoped we could have just like set that and then it would do like the default. That it would just print the constructor. Because there's so many constructors that it seems silly to like list them all out. If I'm just trying to read one type of image, you know. Let's see. Maybe we can just okay. Maybe we should do that. Let's just list all the constructors, like whatever. We can do that. Okay. There's an airplane flying by. You might hear that. Okay. Okay. We need some macroing stuff here, I think. Okay. 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 So let's see. Print, or yeah, let's call it dynamic image to string, takes a dynamic image and returns a string. And let's see, dynamic image to string takes a dynamic image. Okay, and then we match on all of these. Boom. Parse error. Oh yeah. And then all of these should just be I think, right? Wait. Yeah. Let's try doing that. Replace image whatever with I. Maybe we should match the spaces in front of it. Let's see. I don't really. Yeah. I. Space I. Let's go. Is put string line I. No. Show I. And then instead of that, we do. Okay, can you not match like? Okay, I need to read how guards work or pattern. Is it are these guards or like what? I think those are guards. learn you a Haskell guards. Syntax in function, yeah. Syntax in function, pattern matching, blah, blah, blah. Guards, yeah. How do we match multiple things at once? I'm fairly certain that's possible. Nope, maybe not. I really thought Haskell multiple guards, same multiple guard cases, same result. Can a guard have more than one result? No, I want to do the opposite. Come on, this can't be that hard. I'm pretty sure, wait, okay, let's put this in comments for a minute. Okay, are there multi-line comments? I don't know. Okay, this should also be in comments. And then we can say here, guard test goes from either A or B, or man, goes from either string to a string. Guard test either, let's call it E, and it goes if left S or right S is blah blah. Yeah, that compiles. I knew this worked. Oh, parse error. Oh, tab characters. Man, I should set up my. I thought I installed like a plugin. Oh. I thought I installed a plugin that would like. Come on. You cannot match multiple things. That's ridiculous. Blah, blah. Oh my God. Couldn't match expected type bool. Okay, wait. I don't want to use guards. I want to use matching, pattern matching. But how do I match multiple things at once? Is that not possible? Haskell match multiple things at once. Multiple pattern match. Here we go. Multiple pattern. In this, you can use a guard. Oh, here he does it. Huh? XLM AB. Yeah, no, that's not. Okay, back to basics. Okay, we can just like. Let's remove all of that. Let's see here. Okay. Yeah, we can do this thing. Dynamic image to string of I. Oh my God. And then after everything, no. how do you append every line of a selection in VI? I don't know. Okay, let's replace I, nope, space I with show I. Let's go, and then the type is not string, but it is IO, or I don't really know what that. Show. Oh, it converts something to a string. Okay, so we can, oops, we can say string. Let's go. The constructor should have one argument, but has been given the pattern. Okay, so I think all of these need to be in quotes. How do we do that? We replace a space, and then whatever up to equals with that, no, with that. And this should be, wait, no, like that, and then equals. Okay, that does something. I mean, that compiles, you know. So we can delete this here, guard test, remove that. Oh my God. Image is not showable. So, and what if we now here say instance show image of anything? Okay, wait. What? Let's just, it's a warning, so maybe it just works, you know. Put string line. Oh yeah, and now we need to do right. Okay, wait. Let's write image takes a either of string and dynamic image, and it returns dynamic image. Write image, write whatever is that, and this needs to be in parentheses, and then we say here put string line, write image JPEG dynamic image to string. Boom. Reload main. Oh, now it hangs. Stack Overflow. Okay. Okay. What happened there? Stack Overflow. I thought Haskell was a safe language. What's happening? This is going to be a lot harder than I expected. Maybe I should like time how long I've been going. I don't know how to do that. So now it's 10 past 7. Let's say I end it at 7:45. Okay. So that no let's go back to the image. Okay, Haskell print vector, because an image was just like vector, right? No. Data vector, mutable. there's a couple things going on. First solution. Okay, you take a show. What the fuck is that? Freeze, print. What? Oh my God. Let's see here. Vector version 13. Reload. Import data vector. Nope. Cabal repo. Let's hope this doesn't take too long. Oh, what? Oh, it was a hidden package. So, okay. Import data vector. Now, what is that? Data vector. Oh, vector. Okay. Import data vector. Ooh, what is a vector? Vector. So it is, oh, a vector is showable. Hell yeah. And I thought an image was just, wait, image. An image data. Oh, but see, this is a different kind of vector, it seems. I don't know. Okay, wait, maybe we can ask, oh. What is that? What is that? Instance show. So I think it might be showable. So first we, oh, so an image is a struct or something? I don't really know what that means. Okay, so those things are just functions you can use to get data out of a struct. So we can ask like image data from the image, and that should be showable. Okay, let's see. Oh, yeah. Is there a? Okay, whatever. Okay, so show I. Maybe I should just replace all of these. Okay, wait. We need to think about this. Let's just say image. And then we say here, instead of toString, okay, let's replace that everywhere. toString, toImage. Yes. And then here, show I, that should just be I. And then there, what is it saying? Image. Expecting more argument. One more argument to image, okay. So just any image. Does that work? No. Couldn't match A with pixel 8. Oh my God. So there's many types of images. Oh my God. Maybe we should use like a higher level language, higher level library or something. Because this is crazy. image. Why is a dynamic image not showable? That would be so much easier, you know? Instance ec dynamic. A dynamic image is an instance of itself. Oh, dynamic image is both a type class and a data type. What the hell? Defined in codec picture types. Couldn't match A, type A. Can't we just say like, okay, A is just anything or something? Like dynamic image, A, like that. Wait, something like that. No. Expected a kind. Okay, any. Nope. Type constructor. Something that's showable. What is he gonna say now? Couldn't match type A. No, but I don't wanna. I just want any type, you know. Was an image showable? Couldn't match. A is a rigid type variable bound by. Okay. Okay. What was that method again? In image data. Let's see here. Image data. Couldn't match type A with vector. Okay. Wait. Let's see here. If we just say, okay, this has to be a vector. Import data vector? Question mark? Is hidden. Oh, what the hell? Okay. I thought we added that to Cabal, right? Let's see here. Vector. Yeah, we definitely did. Oh, why is that in red? Oh, that's my cursor. Okay. Vector. Okay, so I think we just need to reopen that. Nope. Wait, how do I... What? App main. Okay. Okay, so that works. Dynamic image to image, so that just should be... What? How are those others like working? It can convert an image to a vector automatically? That's strange. Wait. Okay, vector. Expecting one more argument. Vector has kind star to star. Oh my god. Wait. So a vector is not a type, but it's a kind? So a kind is like the type of types, right? Like the kind of just a normal type is like star, and then a kind of a type constructor is star to star. So I think it's saying here vector is a type constructor, right? Instead of just a type. So maybe we can just say vector. Wait, let's see. Vector. A vector of ints. And foreign pointers. What the fuck? Okay, let's see. So is a storable vector, is that also a vector or not? I don't know. Let's see. How can we just say, okay, vector of int and foreign pointer, whatever that is, foreign pointer. Oh my god. redundant bracket. Oh my. Expected kind, but vector int has kind star. Okay, maybe we should say this. What the fuck? I don't fucking know anymore, you know? Oh my god. But, okay, storable vector. Type, not in scope. Storable vector. No module. Data vector, storable vector. Type constructor or class. Data okay. Data vector storable. Okay, so maybe we just need to import storable. Data vector int has kind star. Okay. Couldn't match type data vector with data vector in. Okay. Word, whatever that is. Nope. Maybe you want to add word 8 to the import list of foreign what? Man, I thought. Couldn't match type data vector storable vector GHC word. GHC word 8. Import GHC word. Couldn't match type word A with A to. Oh, I should remove this thing. Yes, okay. We're getting somewhere. Replace, no. Replace space I. No. Equals space I with image data I. Let's see. Oh no. What the fuck is this? It can also be a word 16. What the fuck? This is too hard. What? I should maybe go back to the basics a little bit, you know. Expected. Okay. Let's just delete those where it gives errors, and then we can do the okay. Now, so we have dynamic image to image. So we should probably to image is to word 8 vector. Okay, and now we say here not to image but dynamic image to word 8 vector, and then we just slap a show on there. Boom. Use print. Found println. Why not print? Oh, whatever you say, boss. Print. And then we can remove this. And then we reload, and then we do main. Whoop. Okay, I think we got somewhere. So we managed to load. Okay, so I think that means that we matched one of the constructors. So we were just lucky in that case. And we managed to get out a bunch of values. So these values, hopefully they're just pixels. That would be like amazing. Then we can start working with these. Let's see, it's 7:30. Maybe we just end it off here for episode 1 of reading images in Haskell.